Yo, what's going on, man? What's happening? So today, as you can see, now we have multiple essential nodes, right? As you can see, hold on, let me get my marker out. You can see we have an essential node here. We have three circuit elements being connected here. We have three circuit elements being connected here, right? And doesn't look like anywhere else on this are there multiple circuit elements being connected by, of course, unless besides ground. So we have a total of two essential nodes here, right? I mean, ground's an essential node too, but ground is ground, so we don't really worry about that. I guess a better way to say it is we have two unknown essential nodes. That's a better way to say it. So yeah, all right. And like I said, there's not really. Oh no, what did I do? Okay, there's not really anything special going on about this circuit. So this is just building up on everything we have learned so far. So let's tackle this circuit now. All right. So let's start labeling the points we know. So obviously ground is going to be 0 volts. Ground is going to be 0 volts. So let's label that. All right. Now let's start breaking these sources one by one. All right. So as we can see, the positive terminal right here is connected to ground, right? So the current's gonna go through this, and we're gonna have a voltage drop of the voltage difference of the battery, right? And the voltage difference of the battery is 70 here, right? Because we have 0 volts here. We got a difference of 70. So in order to have a difference of 70, we need negative 70 volts here, right? Because again, we're getting a voltage drop by going through the positive and the negative terminal. So let's go ahead and write that so we know that voltage. Let's go ahead and write that. Gonna have negative 70 volts there. All right. Negative 70 volts. Here we go. All right. Now, do we know the points on this voltage source right here? It doesn't look like we do, right? Because we're going to go from 0 volts to an unknown voltage, right? We don't know the voltage here. And, or my bad, let's use the normal one, right? So we're going to go from whatever this voltage is to 0 volts, right? And then we go all the way around, right? Then again, of course, we don't know what VA is, and we're going to go through here and we're going to get some voltage we don't know. It just needs to be a voltage difference of 50, right? So therefore, obviously, we can't know that one. Now, of course, we know like 5 amps are flowing through this circuit, right? We know that, right? Because like this is the current source, and it says we have 5 amps, right? We have 5 amps here, so we're gonna have 5 amps going through this whole series circuit right here. This one wire, we're gonna have 5 amps going through it. And as we can see, this is the positive terminal of the current source. This is the negative terminal of the current source, right? We're going from positive to negative. Now, in a voltage source, going through positive to negative is a voltage decrease. But as we know, current sources are opposite to voltage sources, right? So going from positive to negative through a current source, that's going to be a current increase. So we know we're going to have a current increase there, all right? And we're going to, of course, we're going to go from ground negative to positive, right? As we go from negative to positive, um, this current source, we're going to have a current decrease, right? Because, going negative to positive through a voltage source is going to be a voltage increase, while going negative to positive through a current source is going to be a current decrease. All right, so we've learned everything. Now, let's get to solving. Let's do that. All right, here we go. Don't save. Okay. So we're going to let's find the current in our first wire, right? So we're going to have VA minus, right? Minus, so we're going to have the voltage difference across this resistor, right? And we already found the voltage right here, right? So let's do the voltage difference across that resistor. We're going to have VA minus negative 70 volts, right? It's going to be VA minus negative 70 volts, right? And that's going to be divided by the total resistance of that wire, which is going to be 50, right? The resistance of that wire is 50. All right, so we completed that wire. We found the current in that wire. That is equal to the current in that wire. All right, so now we're going to do VA minus the voltage difference of that wire, which is going to be 50, right? So we're going to do a VA minus 50, right? VA minus 50. right? And we're going to divide that by 55, just to help you guys stay focused or whatever. As you can see, as we go through this, right, from ground to negative to positive, that's going to be a voltage lift, right? And we go through here through VA, right, as you can see. So it's going to be VA minus 50, right? We're going to have VA minus 50. And again, the reason why it's minus 50 is because voltage difference equals high potential minus low potential, right? Voltage difference, oh shit, put that here. Voltage difference equals that, right? High potential minus low potential. And as you can see, we have the low potential, which is the battery, right? The voltage difference of the battery, right? And then we're going to have the high potential VA, right? And we know this is a voltage lift of 50 volts, right? As we go through that, as we go through these resistors here, from negative to positive, that's going to be a voltage lift, right? So therefore, if I can find my notepad, therefore, we're going to have minus positive 50, right? We're going to have minus positive 50. Right? That's going to equal positive 50 minus positive 50, right? So I just want you guys to understand that. Just to make sure you know. All right. So as you can see, we already know the wire. The amperage in this wire. So what we're going to do, actually my fault, because we haven't got to that point yet. My fault. So we're going to do what? Ooh, we actually didn't even label these points. My fault, guys. We're going to do VA, right? That's VA. And VB. This is VB. All right, there you go. We labeled our essential nodes. Okay. So now we're going to travel from this side, right? We're going to go from ground to here, all the way through here, right? So we need to find the resistance across this resistor, right? Because this is a series circuit, right? We're not going to worry about this one right here because, this isn't in series with this, right? So let me make that clear. All right, so this circuit right, this wire right here is not in series with this wire, right? So we're not going to focus on this wire right here. We're just going to focus on the voltage difference across these two, right? So let's write that down. So we're going to have VA minus VB divided by 50, right? Let me see how I'm doing on time. How am I doing on time? Okay, we're doing good. All right. And that completed that equation, and that should all be equal to 0. All right. 1.0. Here we go. All right. Now we can write our next equation, right? So we're essentially just making two equations, right? Since we have two essential nodes, we're making two equations for those. Because before we've been only having one essential node. Now we have two essential nodes. So we're essentially just going to make two equations for the two essential nodes, right? All right. So now let's do that again. Let's repeat our process. All right. So we're going to go from ground, right, through here, and then we're going to have VA. We're going to have this right here. And again, we're not going to worry about this because this is a parallel circuit. We're only worried about the series circuits, right? And as you can see, this is in series with VB, right? This is in series with VB. So let's write that down now. So we're going to have VB minus VA divided by 50, right? And then we don't have to do anything here because we know the current, right? The only thing we have to do is to see if this is a current increase or a current decrease. All right, so we're going to go from here to the positive, from positive to negative, right? Now we know, as I said, positive, negative in a voltage source is going to be a voltage decrease, right? Positive to negative in a current source is going to be a current increase. So we just got a current increase there. So let's do that. We're going to write, we got a current increase of 5 amps, right? We got a current increase of 5 amps. Put that in parentheses just so we don't get lost. All right. And let's look at this here. All right. So as we go from ground through this current source, right? Positive, we went from negative to positive, right? So negative to positive and a battery is going to be a voltage increase, right? So negative to positive in a current source is going to be a a current decrease. It's going to be a current decrease. So let's go ahead. Let's write minus for the current decrease, and that's going to be minus, or we could do plus. We can also do plus. Yeah, we can do plus -6 amps, right? Plus -6 amps. All right, there you go. And all of that should be equal to 0. This is going to be equal to 0. And now we can start simplifying our equations. So let's do that. Let's simplify the top one first. So we're going to have VA over 50. So we're going to have 50, 55, and 50. All right. So let's go ahead and type that in the calculator. Okay, we're going to have 1 over 55, or 1 over 50, plus 1 over 55. Oops. 1 over 55 plus 1 over 50. And that is going to be equal to 16 over 275. So that is going to be our VA. VA is 16 over 275. Let me see how I'm doing on time. Okay, I may have to end the recording soon and finish the rest of the problem. All right. Then we're gonna have we have a negative VB, right? So we have -1 VB 1 over 50, right? All right. Let's pick up where we left off. Okay, here we go. So we're gonna do negative. We're gonna have positive 70 minus 50 over 55, right? Because we have positive 70 plus negative 50 over 55. So let's go ahead and do that. So we're gonna have 70 over 50. Well, hold on, write that in fraction. 70 over 50 plus, or my bad, minus 50 over 55. I got it and write it in a fraction. 50 over 55 is going to equal 27 over 55, positive 27 over 55. So that's going to make that a negative when we bring it to the other side of the equation. So let's do that. All right, now let's simplify the last equation. We're going to have 2.1. All right, so we're going to have negative VA 1 over 50. And we're going to have positive VB 1 over 50, right? And then we're going to have -6 plus 5, which is going to be equal to -1. And we bring that to the other side of the equation. That's going to be a +1. Now we can use our handy-dandy scientific calculator to solve this equation. If you guys don't have a scientific calculator, I will leave some in the description. I don't know if they work on iOS, but they work on Android. So if you have an Android, you have that. And if you don't have that, or you don't have a phone at all, or nothing like that, I can put some ways in the description that'll help you solve this. So let's go ahead and solve this. So we got 16 divided by 275. All right, and then we're gonna have -1 over 50, right? And then we're gonna have -27, 55, right? And then we're gonna have -1 over 50. We're gonna have 1 over 50. And we're gonna have 1. All right. So we have VB or VA is equal to 13.333. So let's write that. VA is equal to 13.333. And VA is equal to that. Okay. And then we're going to have VB is equal to 63. VB is equal to 63.333. Let's see if that's true. All right. And as you can see, that is indeed true. VA and VB. There you go.